Hello students, good morning. I hope you all are safe and healthy at your home. In previous four lecture in unit 1 paper number IC-302 we complete all theories, and in this lecture we use flow sheet diagram for instruments. So now we draw all flow sheets by in this lecture. So we start drawing for flow sheets. For measuring or measurement of radiation, we discuss three instruments. Number one is sunshine recorder. Instruments used for measuring radiation. Solar radiation is measured by three instruments. One is sunshine recorder. Second one is pyranometer. And last third one is pyrheliometer. So in this lecture we first of all draw flow sheet diagram or a schematic diagram of sunshine recorder, and one by one we see pyranometer and pyrheliometer. So we start with sunshine recorder. We also discussed sunshine recorder in previous lecture. Sunshine recorder. It is an instrument. First of all, it is based on a platform. This is vertical bowl. Now we state nomenclature of different types of sunshine recorders part. This is sphere and this is glass sphere. glass sphere. This is spherical bowl. This is spherical bowl to hold paper. This is marble base stand. This is platform. And this bowl contains paper card. We draw paper card in this side. This is card paper. And we see mechanism when solar radiation is passed, then this card burn out, and we show the image on the strip or card paper. This is the sunshine recorder, and the sun rays when radiation takes place on spherical bowl to a point on a card held in a groove in a spherical bowl. This is spherical bowl. Whenever there is a bright sunshine, there is a bright sunshine, the image form and burnt a spot. We draw here burnt a spot on a card throughout the day, and movement of the sun move across the skies, the image move along the strips. So this is the sunshine recorder. This instrument is known as sunshine recorder. Now we draw second instrument's figure. Our second instrument is pyranometer. And we discuss for pyranometer we have two instruments, pyranometer for global radiation and for diffuse radiation. We also discuss theory of types of radiation. We have three types. One is beam or direct radiation. Solar radiation received at the Earth's surface without any change in direction is called beam radiation. Second one is diffuse radiation. Radiation received at the Earth's surface from all parts of the sky's hemisphere after being subjected scattering in the atmosphere is called diffuse radiation. And third definition, total or global radiation, sum of beam radiation and diffuse radiation is called total radiation. So when we add or sum of beam and diffuse both are calculated, it is known as total or global radiation. So, according to pyranometer, we have two pyranometer. One is measuring for global radiation and second one is for diffuse radiation. So, first of all, we see pyranometer for measuring global radiation. Pyranometer for measuring global radiation. It is contain concentrating glass domes. So first of all we draw a plate. This plate This plate is known as guard plate. This is guard plate and it contains concentric glass domes. This is made up of glass and hemispherical concentric glass domes which contains in center a black surface and this is joint inside. It contains top plate. This is top plate. This is leveling screw. When whole figure is complete, then we give names of different parts. This is platform. Now we draw internal parts. Here this is leveling screw. This is grouted bolts. We draw grouted bolts for performance of platform. Now we give names of different types of parts used in measuring global radiation. This is pyranometer. First of all, we give here a name. This is concentric glass domes. Concentric glass domes. This is black surface. Black surface. This is guard plate. GAURD, guard plate. This is wooden plate. This is top plate. This is leveling screw. SCREW. This is leveling screw. This is mounting plate. These are in both sides. This is also a leveling screw. Grouted bolts. Grouted bolts. And this is platform. This is pyranometer. For measuring global radiation. Global radiation. So this is the diagram of pyranometer. Pyranometer for the global radiation, and we discuss types of global radiation. So when sum of beam radiation and diffuse radiation is calculated, then it is known as global radiation. Here two concentric hemispheres, one is 30 mm and second one is 50 mm diameter, made up of optical glass having excellent transmission characteristic, are used to protect circular disc. Are used to protect circular disc. It is an instrument for measuring global or diffuse radiation. A hemisphere field of view, it consists of black surface. We here describe black surface. This is black surface. Black surface which gets heated and when exposed to solar radiation, its temperature rises to extent such that rate of heat gained by solar radiation is equal to rate of heat loss by convection, conduction and radiation. So this is very important measuring instrument, radiation measuring instrument. And one more important point we also discuss in previous lecture, but when we draw this figure, I state out the EMF when this hot black surface is thermopile and connected to junctions where no radiation are coming. So EMF of is generated and it is in the range of 0 to 10 millivolt. 0 to 10 millivolt MV. 0 to 10 millivolt. So it is very important. This is pyranometer. Now we draw figure for the pyranometer for measuring diffuse radiation. I rub out this figure and we draw diffuse radiation measuring instrument, that is pyranometer. In this instrument there are a black surface. I draw with the help of black pen. This is black surface which absorbs solar radiation. This is rectangular table type instrument. And it have aluminium shading ring which transmit the solar radiation. Solar radiation. Now we give names. Aluminium shading ring. This is aluminium shading ring and it is 50 mm wide. The radius from the black surface. This black surface is protected by glass cover and this is the radius in between black surface and aluminium shading ring and this is 450 mm radius. Radius in between black surface, here we write down this is black surface. So radius is 450 mm and this is pyranometer. For measuring diffuse radiation. diffuse radiation. And also we see concentric spherical optical glass. This is spherical glass cover, and this optical glass having excellent transmission characteristic. So when solar radiation takes place on this spherical optical glass cover, it absorbs and measure diffuse radiation, and this can be done by measuring it at the center of a semicircular shading ring. This is semicircular shading ring. The shading ring is fixed in such a manner, that is, its plane is parallel to the plane of path of sun's daily movement across the sky and its shapes. It is very important point. Noted that semicircular shading ring is fixed. Semicircular shading ring is fixed in such a manner that its plane is parallel to the plane of path of sun's daily movement across the sky and its shapes. Across the sky and its shapes. This is pyranometer for measuring diffuse radiation, and we have last instrument remaining, third instrument. So we discuss and draw. This is pyrheliometer. 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 It is an instrument which is measure beam radiation. So first of all we draw figure of pyrheliometer. First of all we draw main parts of pyrheliometer, and that is acceptance angle and very important parts thermopile and black absorber plate, which are in this unit. So first of all we draw this unit. This unit contains black absorber plate. So I draw this plate by black ink. This is black absorber plate. This is platform. This black absorber plate joined with thermopile junction, thermopile junction, and this unit or this plate, this unit is blackened. This is tube type instrument and blackened on inside surface. So this tube's inside surface is covered with black color. I draw it by dotted lines, but it is continue covering inside black. This tube have one alignment indicator. This is alignment indicator. And now we draw acceptance angle which accept solar radiation. The radiation which flow in this angle is countable. Only this radiation is countable. This is acceptance angle. I write down. Acceptance angle. This is alignment indicator. Alignment indicator. This is black absorber plate. Black absorber plate. This is thermopile junction. Thermopile junction. This is two axis tracking mechanism. This is supporting platform. And this tube is tube. Blacked on inside surface. This is the diagram of pyrheliometer. Pyrheliometer. It is an instrument which is measure beam radiation. When beam radiation takes place, the black absorber plate, this is black absorber plate, is absorb the radiation. The black absorber plate is located at the base of the tube, and the tube align along the direction of sun rays, which is sun rays, with the help of two axis tracking mechanism. And alignment indicator. So black disc absorb beam radiation. It is noted that the black disc absorbs only beam radiation and small amount of diffuse radiation falling within the acceptance angle of the instruments. Sometimes more reflecting mirrors for concentration of solar radiation. For concentration of solar radiation, more reflecting mirrors are arranged and more beam radiation are accepted in acceptance angle. For more concentration, if we see here, this is reflecting mirror, so which are reflected, these are direct radiation on this mirror, so it reflects in acceptance angle of the instrument. So sometimes for more concentration of solar radiation, reflecting mirrors are also used. These are the three different types of instruments which measures the solar radiation. First, in this lecture, first we discuss sunshine recorder, which measure the solar radiation. Second, we see pyranometer, and we discuss or we draw two types of pyranometer, one for measuring for global radiation and one for diffuse radiation, and this is pyrheliometer, which used for measuring beam radiation, and sometimes it is also used for diffuse radiation, but small amount of diffuse radiation it is measured, so it is very important for measuring of beam radiation. In this lecture we completed three drawing of our solar radiation measuring instruments. In next lecture we draw device for solar thermal collection and storage. Solar thermal collection and storage. We have three instruments. In these three instruments, devices for solar thermal collection and storage. One is flat plate collector, FPC. Second is cylindrical parabolic collector. And third one is paraboloid concentrating collector. So we draw their figure. We will draw figures of this instrument in next lecture. Thank you.